Your AI stack is not bottlenecked by model quality first. It is bottlenecked by memory, more precisely, by what fits inside the context window at the moment the system has to think. That window decides what the model can see, what it forgets, what it compresses, and what it invents to bridge the gap. If you do not engineer around it, every workflow eventually hits the same wall. Most people treat context like a bigger backpack. They keep adding documents, prompts, notes, transcripts, examples, code, and instructions until the system feels powerful. Then the output gets softer. The logic gets blurrier. The assistant starts missing constraints that were clearly provided, because provided is not the same as usable. The real failure mode is not that the AI knows nothing. It is that it has too much of the wrong thing in front of it at the wrong time. If you are building agentic workflows, SaaS systems, research pipelines, content engines, or automation layers, context is architecture. It is not a prompt writing detail. Every serious workflow has state. There are goals, constraints, prior decisions, user preferences, active files, edge cases, approvals, and open loops. The question is not, how do I stuff all of this into the model? The better question is, what does the model need right now to make the next correct move? Memory and attention are not the same thing. Memory is everything the system could know. Attention is what the model is actively reasoning over in this step. When people confuse those two, they overload the prompt. They use the context window as a database, a notebook, a project manager, and a task runner all at once. A better system keeps long-term memory outside the active window. Then it retrieves only the fragments that matter for the current decision. Context becomes a working surface, not a storage unit. Bad compression shortens words. Good compression preserves decisions. If a project has 10 pages of history, the model usually does not need all 10 pages. It needs the current objective, the constraints that still apply, the decisions already made, and the known traps. That means summaries should not be vague. Discussed payment flow is weak. Use hosted checkout, verify webhook events, do not expose secrets client-side is useful. The goal is not to remember everything. The goal is to preserve the shape of judgment. Long workflows fail when handoffs are loose. One agent starts with rich context. The next agent receives a messy transcript and has to reconstruct intent. That is where drift enters the system. Not because the model is lazy, but because the handoff did not preserve the load-bearing details. A strong handoff includes the objective, the current state, the files or assets involved, the constraints, the acceptance criteria, and the proof required. That turns context into an operational packet. The next system does not restart the problem. It continues the work. Tools should be callable. They should not be endlessly described inside the prompt. A common mistake is pasting tool lists, process manuals, API notes, and workflow instructions into every run. That wastes attention on information that only matters if the workflow reaches that branch. The stronger pattern is conditional context. The system knows how to retrieve the right procedure when the task requires it. Until then, the working window stays clean. You are not paying attention tax on instructions that are irrelevant to the next move. If the model has to remember the state of the project from conversation alone, the workflow is fragile. Conversations are not databases. They are working traces. External state is how you make AI systems durable. Task queues, decision logs, memory notes, test results, completion records, and artifact paths belong outside the model. Then the model can inspect state instead of hallucinating it. It can ask what changed, rather than guessing from a long chat history. That is the difference between a clever assistant and an operating system for work. Context is not free just because the window is large. Every token competes with every other token for attention. So spend context like a budget. High-value context is specific, current, decision-relevant, and tied to the next action. Low-value context is stale, duplicated, generic, or included because nobody wanted to curate it. This is where technical creators separate themselves. They do not just ask better prompts. They build systems that feed the model cleaner information at the exact moment it matters. When you engineer context properly, the whole system changes. Agents recover faster. Outputs become more consistent. Workflows survive longer sessions, larger projects, and more moving parts. You also reduce the need for heroic prompting. The model is no longer trying to solve the task, remember the business, infer the constraints, and manage the project all inside one overloaded window. It gets a sharper job. Here is the goal. Here is the relevant state. Here are the constraints. Here is the next move. The old way is prompt first. Write a huge instruction block, paste everything in, and hope the model performs. The new way is system first. Memory lives in one layer, retrieval lives in another. Execution happens through tools. The context window becomes the temporary workbench where the right pieces meet. That is the shift. You stop treating AI like a magic text box. You start treating it like a reasoning engine inside a larger architecture. So if your AI workflows keep degrading, do not only ask whether the model is smart enough. Ask whether the context window is carrying work it was never designed to carry. The takeaway is simple. Your real bottleneck is not information, it is usable attention. Engineer the context and the leverage compounds. Subscribe for more systems thinking at the intersection of data, AI, and digital leverage. And for the broader ECTD ecosystem, go to ectd.com.au.